Bismillahirrahmanirrahim. In this video we will study about the test for independence. Test for independence in contingency tables. So test for independence used for contingency tables. So what is the contingency tables? Contingency tables is the same as the frequency distribution table. But what is the difference in frequency distribution table and contingency tables? You know that in frequency distribution table we represent the collected data in the form of table with the help of frequencies according to the groups or classification. Same as in contingency table we represent two or more characteristics of the collected data in the form of table, but table is called contingency table or two-way frequency table. So what is the main difference if we represent two characteristics in cross classification? In cross classification means in rows and columns. Why? Because you know that for one characteristic we required rows or columns, anyone. So in frequency distribution table we represent the data in the form of column. So for two or more characteristics we required the rows and columns. If you have two characteristics, we represent the first characteristic in rows, second in column. So when we represent two or more than two characteristics or two criteria of classification in the form of table into rows and columns, the table is called contingency table or two-way frequency table. The classification is called cross classification. Cross means rows and column. So when two or more characteristics are observed for each sample element, the data can be simultaneously classified with respect to the levels of occurrence of each of the characteristics. For example, a sample of employed person, if you collect the data of the employed persons, may be classified according to the educational qualification and type of jobs. For example, suppose if you collect the data of employed persons and you want to study about the educational qualification and type of job that both are independent or dependent. So for test of the independency or dependency we use the test for independence. If you have two variables, two characteristics, two criteria of classification, then we use test for independence. With the help of test for independence we test either the both characteristics, both criteria of classification are independent or dependent. You can study any two characteristics. For example, suppose you can divide the educational qualification into two categories, graduate, non-graduate. Type of jobs you can divide according to the designations. But there are two variables of this employed persons. We test either this variable and this variable is independent or not. First we convert or collect the data according to the criteria, according to the requirement of the study, and then we test either the main variable. Suppose educational qualification is graduate and non-graduate or matric, inter, BSc, this is the subgroup, but main variable is educational qualification, and job, designation of job, type of job, maybe suppose manager, deputy manager, etc. but the main variable is the type of jobs. We test the independency or dependency between the main variable. This is the most important thing. And this is the subgroup categories of this employed person, or characteristic of the employed person, or criteria of classification of the employed person. Okay. Now, a sample of married persons may be classified according to the education and number of children. You can also divide or classify this education into groups: matric, inter, graduate, non-graduate, etc. Then we will represent the subgroup into rows and columns. So when we represent two characteristics or two criteria of classification in the form of table into rows and columns with the help of frequencies or observations, the table is called contingency table. So what is the contingency table? Frequency data which arise from cross classification. Cross means into rows and columns on the basis of more than one characteristic are called contingency tables. Okay. R into C contingency table means row and column. R represent the rows and C columns. If we represent one characteristic into rows and another characteristic into columns, the table will be R into C contingency table. R rows and C columns. So let the two characteristics to be studied be designated by A and B. A is the first and suppose B is the second characteristic, and suppose that there are R categories. R means rows. R categories A1, A2 up to AR. This is a subgroup of A for A. And C category B1, B2 up to BC for B. This is a subgroup of the B. By arranging the A categories in rows and the B categories in columns, we can create a two-way frequency table. Because there are two characteristics, the table is called two-way frequency table. So contingency table is also called two-way frequency table, in which each cell is at the intersection of an A category and a B category. A random sample of n elements classified into these cells produce a two-way frequency table called an R into C contingency table. Now we will construct the contingency table according to the two characteristics. Suppose if you have two characteristics A and B, subgroup of the A, A1 to AR, we will represent into rows. B, subgroup of the B category into B1, B2 up to BC, B characteristic into categories B1, B2, BC for B in columns. So R into C contingency table. This is the rows, first row, second row, third row up to R rows, and vertical line represent the columns B1 first category, B2 second category up to BC, C category in columns. Suppose this is the A characteristics, main variable is the A, here the main variable is the B characteristic, this is the subgroup of the A category for A, this is the subgroup or categories of the B1 to BC. And this is the intersection area, common area. Intersection means common area. So common area of the first row and first column represented by 1, this is the notation represent the first row, first column, or represent the observed frequency or simply frequency. You can also use here F0, F0 for observed frequency. But in formula we use two types of frequencies, observed and expected. So we use the notation O instead of F. Okay. So this is the intersection of the A category and the B category is called cell. First cell of the first row, first column. This is the second cell of the first row 1, second column 2. This is the standard method. First we write the notation of the row and then column. and so on up to in first row there are C columns, and R1 is the total of first row, total of the all frequencies of the first row. Now second row 2, first column 1, observe frequency of the second row first column, second row second column, and so on up to second row C columns. Total of second row represented by R2, and so on up to R rows. R for R rows, first column 1, second column 2, and so on up to C column. The total number of rows and columns represented by R into C, and this is the total of R rows, and total of first column C1, C2, and so on up to CC, and this is the grand total of the only rows or only column or only all the observed frequencies, any one. So Oij, I will vary from 1 to R rows, J column, 1 to C column. There is a standard notation used for I and J for different columns and different rows. O I J means if I equal to 1, J will be 1, 2, 3, 4, 5 up to C. Here R is the 1, 1, 1 fix, J will be 1, 2, 3 up to C. Same as next value of row will be 2, R will be also from 1 to C. R is 2, C will be 1 to C. So Oij means observed frequency of the all cells of the rows and columns. And Ri, if I is equal to 1, will be this value, R1, I will be equal to 2, this will be R2, and so on up to RR. This is the total of rows, and Cj, J represent the 1 to C, first column C1, C2 up to CC. Total number of observation represented by N. Okay, so this table is called the contingency table, or in general R into C contingency table means rows into columns. And there are two characteristics, A and B. This is the categories of the B, this is the categories of the A. For this type of data, this type of table, we apply the test for independence, for testing of hypothesis, for independency or dependency of two variables or two characteristics or two criteria of classification. Test for independence, first part of the main heading is the test for independence in contingency table. There are 6 steps, same as the testing of hypothesis. First step, null hypothesis, second alternate, third level of significance, fourth test statistic, fifth critical region, sixth is the conclusion. A null hypothesis is the fixed two characteristics or two criteria of classification are independent. This is the general statement, but we will write according to the data or question. Suppose if you have two variables, qualification and types of job, null hypothesis will be the qualification, educational qualification and jobs are independent. Alternate will be same as null hypothesis, but this word will be changed with not independent. Two characteristics or two criteria of classification are not independent or dependent. This is a general statement, but we will write according to the statement or question or data. Third step, level of significance alpha. Fourth step, test statistic. This is the formula of the chi-square test. We have used another formula in test for independence for testing of hypothesis for standard deviation and variance in testing of hypothesis, and this formula used for test for independence. In this we require the expected frequency, observed frequency is the given value of the cell frequency O11, O12, and this is the corresponding expected frequencies. So how we find the expected frequencies of the corresponding cell? I will vary from 1 to R, J from 1 to C, same as the observed frequency. Formula of the EIJ, expected frequencies of ith row J column, is equal to total of rows of the corresponding row, total of the column of the corresponding column divided by grand total. RICJ for E11. This is the O11 observed frequency. For expected frequency, notation will be E11. E11 means first row, first column, total of first row R1 multiplied by total of first column divided by n. Same as for all cell frequency, cell expected frequencies, we will use corresponding total of the column multiply the total of the rows divided by grand total. So with the help of this formula, you can calculate all expected frequencies of all the cells, corresponding cells of the observed frequencies, then calculate this expression Oij minus Eij whole square divided by Eij for all these cell, and then add all values. You will obtain the double summation Oij minus Eij whole square divided by Eij. Fifth step, critical region. You have, in this we have only one types of critical region. In testing of hypothesis, you have used three types of critical regions, depend on the alternate hypothesis, less than, more than, or not equal to. But in this we have only greater than chi-square, alpha mu, alpha level of significance, mu degree of freedom, but the degree of freedom is different, number of rows minus 1 multiplied by column minus 1. And this is the critical region, this is the acceptance region. Conclusion is also same as the testing of hypothesis. For mean and variances, if calculated value lies in the critical region, we reject the null hypothesis. This is the general statement, and conclude that two characteristic or two criteria of classification are not independent. If the null hypothesis reject, means this is true, or variables are dependent, characteristic or criteria of classification are dependent. Now we will solve the numericals. If an experiment to study the dependence of hypertension on smoking habits, the following data were taken on 180 individuals. The main variable is the hypertension and smoking habits. This is a characteristic of the classification, criteria of classification. And this is the categories of the smoking habits: non-smokers, moderate smoker, and heavy smokers. And this is the category of the hypertension: no hypertension and hypertension. This table is called contingency table, when we represent two characteristic or two criteria of classification according to the categories in the form of table. The table is called two-way frequency table or contingency table. Test the hypothesis that the presence or absence of hypertension is independent of smoking habits. Use 5% level of significance. Mostly we write the main variable hypertension, like this hypertension and smoking habit. There are two main variable, but this is the group of the hypertension, presence or absence, hypertension, no hypertension. You can also write this subgroup, but in this category you have only two groups, maybe 3, 4, 5. In this maybe also 3, 4, 5. So instead of long statement, we write the main variable, because we always test the dependency or independency between the main variable, because this is the characteristic of the collected data, same data, and this is the intersection, common area of this and this, both are belongs to the sample, collected sample data. The intersection area, common area. So null hypothesis will be hypertension and smoking habits are independent. Alternate will be hypertension and smoking habits are dependent or not independent. We write according to the statement or variables. Third step, level of significance alpha. Fourth step, test statistics. Before the test statistic, test value, we will find the expected frequencies. So how we find the expected frequencies? First calculate the total of the columns, total of the rows. This is the total of the rows, this is the total of column, grand total is the 180, and this frequency for E11, first row, first column, total of row 1 is the 87, total of first column 69, multiply both value, divide by grand total 180, you will obtain the expected frequency 33.35. And frequency is the discrete type of variable we write in whole number. You can also use as it is this value 33.35 for calculation, or you can write in round figure, or as it is. Same as for this second E12, first row, second column. Multiply the total of first row and this column 62 divided by grand total, you will obtain 29.96, approximately equal to 30. And same as for this expected frequency, multiply this column, total of this column and this row divided by 180, you will obtain this expected frequency. Same as for this column, this total of the column and this total of the row divided by 180, and calculate all expected frequencies of the corresponding cell. And then substitute the observed frequency minus expected frequency. 21 minus 33, according to the formula, first calculate the difference, then square, and then divided by Eij, there is no square. Summation, double summation means write plus sign, second value of the first row second column, 36 minus 30 whole square divided by 30. Same as for this cell, this and this cell, all 6 cells. Simplify, you will obtain 12.94. This is the chi-square calculated value. After calculated value, we find the critical value. From the table, we will use the same table, chi-square table you have used in testing of hypothesis for standard deviation. Alpha is the 5%, degree of freedom row minus 1, there are 2 rows and 3 columns. 2 rows, 2 minus 1, 1, 3 column, 3 minus 1, 2, 2 into 1 is the 2. The table value 5.991, and this is the table value, critical region, and this calculated value 12.94 lies in the rejected region. So we reject the null hypothesis because the calculated value lies in the critical region, and conclude that hypertension and smoking habits are dependent. Okay, we reject the null hypothesis means hypertension and smoking habits are dependent. So with the help of test for independence, you can test either the variables or characteristic or criteria or classification are independent or dependent. It does not calculate or measure the degree of the relationship, degree of the dependency, strength of the dependency. For this we use another method after this. So if null hypothesis accept means independent, there is no relationship, no association. But if null hypothesis reject means variables are dependent, there is a association. Association or relationship may be strong, may be weak. So for degree of the association between the variables, after the rejecting the null hypothesis, we find or calculate the association of the relationship. For this we use measure of association in a contingency table, is called coefficient of contingency. We will measure the association in a contingency table. There are different methods, different formulas, okay, for the measure of association. But for measure of association in a contingency table, we use this formula. It is also called coefficient of contingency. So the test of independence indicates only whether or not any dependency relationship exists between the attributes, characteristic, criteria of classification, etc. It does not indicate the degree of association. Or the direction of dependency. For this, when null hypothesis reject means variables are dependent, how much dependent, what is the strength, what is the degree of association. For this, a measure of the degree of association or dependency in a contingency table is given by C, is called the coefficient of contingency, under root chi square calculated value of the data divided by chi square calculated value plus n. And the range of this value C from this formula will be between 0 and this value. And what is this? Q is the number of rows or columns, whichever is smaller. We substitute the small value in this data. In previous example, previous question, 2 rows, we have 2 rows and 3 columns. The small value is the 2. So we will substitute here 2 for the upper value. So if you substitute the chi square calculated value and number of observations, you will obtain the value of C, where Q represents the number of rows or columns whichever is smaller and n is the sample size. The C is called the coefficient of contingency. The larger the value of C, the greater is the degree of association. Large value of C indicate the greater is the degree of association. Okay, so we will apply this formula for measure the association or degree of the association for previous example. In question number 1, we have reject the null hypothesis, means attributes are dependent, variables are dependent. So we will measure the degree of association or relationship. Chi square calculated value 12.94, n is the 180, substitute here value of chi square and value of n, simplify, the value of C is the 0.26. Either this value is the greater or small value or greater value. How you will decide? So with the help of this lower and upper value of the C, we will decide either the relationship association is strong or weak. So substitute the number of rows, 2 minus 1 divided by 2.707. Lower value of C is the 0, maximum value, upper value is the 0.707. So if you divide or find the central value of this and this is 0.35, if you add 0.707 plus 0 divided by 2 is the 0.35. And this value 0.26 lies in left hand side between 0 and 0.35, smaller side, lower side, not upper side. If value lies between this and this more than the central value, indicate greater association. But in this we have small value 0.26 between 0 and 0.35. So the association between hypertension and smoking habits is not strong, or you can say weak, in the sample data or collected data. Okay. Next time we will continue. In next video we will continue same topic for 2 into 2 contingency table, because for 2 into 2 contingency table we use different formula. For homework, page number 3, 143, question number 3. Allah Hafiz.